Hey guys, I've got my Arduino project here. I'm just going to kind of talk about it a little bit. So I've got it all hooked up onto this 12-volt battery, which goes into this noise reducer and voltage reducer. And then through that goes into my voltage gauge and my other gauges. So pretty much what I'll explain is the 7.4 volts is for my LED lights. This one is for the Arduino chip itself, that Mega 328. Which is one of these guys right here. And that guy gets plugged in right there, and that's pretty much what powers the whole board. That's what you program anyway. And then I've got my 5.5 volts, and that is for my servo motors, which are right here. So this is my chip board that I've made. I've got it all set up like this. Just kind of show you guys the back. I have made an update on future boards. I'll have this exact same screw terminal setup, something a little bit bigger, more robust for right here. And it also has the capability of going with smaller connectors, which these are the exact same thing, just on a bigger scale. And the only thing is, like with these ones, I will be adding the bigger set on the back as well, and the reason for that is in case somebody in an older vehicle, like the Corvette is what I made these for, the alternators in the Corvette don't have to be held to the same standards as today's vehicles, so the AC ripple can be a lot bigger in a newer or an older alternator than it can in a newer alternator. So what ends up happening is even when you go and get aftermarket gauges, you'll buy the aftermarket gauges and then they'll slowly fail, and you'll ask yourself, well, why are my brand new gauges failing? Why are the LEDs going out? Maybe you just put a brand new radio in there and you'll notice that the screen will start to dim and fade out, or get liney. I can try to mimic what it would do on my phone maybe, but it could like show lines or flicker and stuff, and that's due to the fact that the alternator can be not saying that this is 100% every time that this is the reason. I mean, components and stuff wear out, but it could be that the alternator is sending a reverse current or AC current ripple through your system, and that is shorting out your stuff. So what I got in here is a noise reducer for that. I'm seeing that it's going to be on an older car. Obviously I can go way smaller than this. This is using these big ones. This is for my display setup, just to kind of show you guys what I got going on. And then in here, I've got these all come out here into a pigtail, which gets right here. I'm using the older style spade and female connectors like you would find on these older cars anyway. Just kind of making it all nice and neat, as clean as I can. I like to be particular. So right now, I kind of will explain this a little bit. I've got my this is my high temp coolant light, this is my check engine light, this is my fuel light, and this is my battery light. I won't be able to get my battery light to go off for us, seeing that I don't have this hooked up to an alternator, and it's 12.1 volts is coming off this battery, so it's pretty dead right now. It's been sitting up here and I've been doing a lot of testing on this battery, so it should be 12.6 on a fully charged battery. Maybe 0.1 plus or minus 0.1. So it's actually pretty, it's not fully charged is the best way to say that. So I will click that back up to where I had it, and then I will kind of get all my other lights to kind of go off and show you guys the gauges in action. So I've got them all hooked up to an LED board right here. Not LED boards, but I got my LED lights, and them are all off of a potentiometer switch, so I can dim them, which bolts right up into the C3 Corvettes. If you guys watch one of my videos, you'll see what I'm talking about on that. And I will go through here and show you guys how I kind of calibrate these. So this is my alligator clip on a female, and I put it into the one that I need to. Right now we're on the fuel, and as you can see, I've got it set up to where it's going to be in the half tank mark, and this is kind of my calibration setup. I also have a program in here as well that will put all these gauges at 90, and then I can just push the needles in off that. And it's actually very, very accurate. So we'll go to my fuel, we'll make my fuel gauge, my fuel light come on. So as you can see, I made my fuel light come on, and this is also going to drop down now below the threshold that I set in the program to allow the fuel light to come on. So now if I go back to the half tank, or above a half tank, so actually we'll go right above a half tank right here, and my fuel light's going to shut off. Now this is set up for my oil pressure ohms, so it's not going to be quite a half tank, but it'll be kind of close to it. So there we go, 3/8 of a tank, and that's for my oil pressure. So with that being said, let's hook up my oil pressure. So let's see, that's a coolant temp, and now here's the oil pressure. Alright, so I just plugged that into the oil pressure. As you can see, my oil pressure is going to go up, and we will get it right in the middle to where I would set that at. So I'll show you guys right here. So there we go. And this is the center of where my actual sending units are going to put. I've done all the math and all the calculating and all that stuff in my code here, and I've got it all set up to where I know where the ohms and stuff are for each sending unit I have, so it will correlate really good with here. These my coolant temp is to me is one of the, and my oil temp or oil pressure are the two most important ones. So this one I have set up to where exactly at 200 degrees. I found out what that exact ohm was, and I've set that to where my most accurate spot is going to be 200, plus or minus 10 degrees right here. And when I say 200, it's going to be dead on 200, but so you got 180 to 200, so this is 180, 190. So 190 to 210 right in that area it's pretty much dead on. And I did that on purpose because you really want to know where your coolant temp is at. So now that's the oil pressure, and as you can see, my check engine light came off. My check engine light will come on with the oil temp as well, but with the oil temp, it's going to start cold, so there's no reason to have the check engine light come on for that. So we will go to now the new one, or the next one, which is my coolant temp, and it's going to peg out because the ohm resistance on the coolant temp are going to be that I left it on the oil, so it's going to peg out down here pretty far. And the reason for that is because it's going to overdo the temperature, and then it's going to hit the threshold, which made it go pretty much the high coolant temp is going to come on for that reason. I kind of go through it, let you guys just watch it step. Now before I had these very responsive, but the problem with having them responsive is when the fuel would splash around in the tank, this thing was bouncing just like it would in a 1981 or older Corvette. It was just bouncing, and so it was kind of loud, just because the servo motors in general are loud. And so what I did is I got them all set up like that, so you can barely even hear these now. So now we'll go back to where I would set my coolant temp at, which this is the exact ohm for it, or ohm is the exact resistor, which is the correct ohms for the sending unit. And then that's where I set this guy at. Alright, so there we go. And now I'll do my last one, which is going to be my oil temp. Make sure I get the right one here. There we go. Alright. So now my oil temp is going to go up to 200. It's set to like 203 degrees exactly. So there we go. And So pretty much that's what I got going on here. I'm gonna do another chip with just the warning lights without the gauges. And so if somebody like me, they can't acquire a low fuel warning light for a C3 Corvette, or maybe it's a different car that you want a warning light to come on for, low fuel light, maybe your gauge stopped working and you just want to buy something, just a warning light. I'm gonna make a little box, pretty much plug and play, and then it'll have the warning light come out based on the resistor. Same with these. If there's interest in that, definitely let me know. Kind of want to start doing a little bit more of these projects like this going on. So hope you guys like it. Kind of, you know, this is all pretty much my stat chart. Just my serial monitor, pretty much what I got going on here as I was setting the gauges up. As I said, 203 degrees, so right there. And that's my water temp, which is also my coolant temp right here, which I'm not all the way at the bottom. I got it disconnected right now, but as you can see, I got my oil pressure ohms. It's reading infinity because nothing's hooked up right now. And then my fuel, all that. And they'll actually, all that will read like that just because it's not even hooked up to the computer. That is hooked up off of this guy right here, and then this gets plugged in right there to that, onto this chip, and then this chip gets plugged into my Arduino board, which is right here. So this is actually the new one I just made here recently to kind of get everything, streamline it, make it a little bit better. This is my pretty much prototype testing board that I've done all my tests and stuff on, and was doing my wire pigtails. As you can see, I've changed it. This is the aluminum kind of copper, you know, blend wire, which isn't as good as the solid copper. So all this gauges, just using solid copper wire, just better, better for the long term. Short term, there's really not a advantage, but definitely long term, the copper is the way to go. Or solid copper wires. It's stranded, but it's 100% copper opposed to aluminum and copper. So that's just a prototype. You know, like when you're wasting a lot of wire, it's a good wire to use for prototyping, but not something to actually put inside your car, in my opinion. So hope you guys like this. If you guys got any comment suggestions, maybe you wanted me to do another video or something like this on this, let me know. Thank you guys for watching.